So the SLCP benefits assessment tool is basically an Excel spreadsheet that's been set up to accept input emissions data from whatever source. In this case, we're going to input the data that we produce from the LEAP part of the toolkit in order to assess impacts on, in this case, health, but we can also assess impacts on crops and also climate forcing using this tool. Within the tool we have lots of spreadsheets in which there are transfer coefficients that have been produced by the Geochem adjoint model. In this case we're going to look at the impact of all the pollutants involved in generating particulate matter concentrations that impact on health. So those are the coefficients that have been generated that will show what will be the final impact on PM concentrations in the target country from a change in emission from any particular grid cell. In this spreadsheet we have default data for the whole globe that are there for each grid, covering all the grid cells outside the country as well as the grid cells in the country itself. And then the input data from the LEAP tool will replace those default data with the tailor-made data, and the impact of changes in those can then be assessed. First of all, in the spreadsheet we have the summary part, which is a tab that shows the area where you can input data from LEAP. So here we have all the different pollutants involved in particulate matter listed on the left, and you can see the across the top. We have first of all the historical year 2005, so those data go in there. Then we have the baseline scenario year 2030, this is business as usual, so the emissions go in there for that scenario. And then the next column is the coke oven scenario, in which we've now inputted the LEAP data there. So this is the part of the spreadsheet where we input all the emissions data, and then we need to have a look at the impact that's going to have on health. So in order to do that we have another part of the spreadsheet where we have other variables that are required, such as the population of the country concerned and the likely population in the target scenario year 2030 in this case. And then the health calculations are based on those who are aged over 30, so we need to know the proportion of the population that is aged over 30. And then we have the disease rates due to particulate matter exposure for each individual country can be entered, and then the relative risk is also needed, and these together can be used along with the emissions inventory results and together with the resultant change in particulate matter concentration using the coefficients in order to work out what will be the total health burden as a result of the PM exposure. And this graph here shows that in the historical year just over 1,500 premature deaths each year would occur in Colombia due to its own emissions. Some other mortality would also be due to emissions from elsewhere, but domestic emissions would cause that number of deaths each year. In the baseline scenario, business as usual, this burden increases to 5,000 premature deaths each year in Colombia due to the emissions that cause the particulate matter exposure to the population. So what will happen if we carry out the mitigation measures, i.e. transferring coke production from traditional to modern ovens? And we can see in the third column here that the policy scenario will reduce to just above 4,000 the premature deaths each year, amounting to a difference of 830 deaths each year that will be prevented by implementing measures to switch production from traditional to modern coke ovens. And so you can do the same thing. You can construct another scenario for another mitigation strategy and assess the likely impact of that strategy as well. In that way you can compare different alternative strategies and work out which will be the most effective in terms of preventing deaths in the target country. The toolkit is also capable of looking at the impacts of ozone concentrations on crops, so you can measure crop yield impacts as well. And finally, the benefits calculator will also enable the user to assess impacts on climate forcing of all the relevant pollutants emitted, and so see what effect that would have on possible changes in temperature of the globe.